Sorry for the delay because we have some internet connection problem. I need to connect from my computer so that after I can say a brief demo about the OI5 network and then also about the network slicer. So, so my name is Thien-Thinh Nguyen. I'm a senior researcher at EURECOM, like Raymond, and also I'm the leader of the 5G network project. So in this talk, I will first give a very brief high-level view of the 5G system architecture, and then we talk about the OI 5G core network implementation. And then we have two demo. First one just show you the end-to-end connection using OI 5G core network, OI VFD, and OI EV. And then we talk about a little bit about network slicing, and then we have a very deep demo with that. So let's start with the 5G core system. So let's start with the Chrome 4G. Maybe some of you already know about 4G, so we start from the traditional EPC, and then the control and user plane separation. In the traditional EPC, you have NME, SSH, S gateway, and T gateway, and forming component. And then in the control and user plane separation, basically the S gateway and T gateway divided into control plane part and user plane part. And also the figure you can see on the right side of you is the mapping between the 4G and 5G components. So at least you can have the idea of the 5G core network component. So basically the functionality of the, you can have the list, full list of the component in the next few slides, but here you can see that the main functionality of the AMS access the mobility management function is come from the mobility management part of the NME, and the SNS is actually the section management part of the NME, and then the control plane part of SP gateway. And EPS is basically SP gateway E and C, sorry, P gateway E. And the functionality of the SSH is divided into a USF and EDM, and for the and also there are some more network functions, basically for the 5G scenario. For example, network repository function to support network function registration and discovery. We have also NEF, that means for the network exposure function to expose the internal information from of the 5G network to the third-party application. And then you have NSXS for network slicing management. You have EDR, and basically to store the TCP/IP information. And you have EDSF, which is basically to support static implementation to store the non-TCP information. And let's see the 5G system architecture. So thanks to the professor Yuki yesterday, he already mentioned about the history architecture, right? You can see that this figure is quite new. So in this, the idea is that to SBA design for the parametric deployment. So the goal is to remove the telephone style protocol such as VPC, VPC, diameter, and then replaced by a more friendly protocol in web by API content. And the figure, you can see figure on the right is represent a more traditional way to represent the network. So you can see the point-to-point representation. For example, we have the interface between AMF and SNS in M11, the interface between SNS and EPS, and for some important one is N1 between EE and AMF. You can cover this later on. So a bit more detail about service by architecture. So the service by architecture is a system in which the system functionality is achieved by a set of network functions. So providing the services via the authorized network function. to access the service. So you can see in the next few slides that SMS can acting as a service producer to provide the services to the INF to create the PD section on behalf of the EU. So there are some interaction between the network function service consumer and producer, for example, request and response and subscribe notify. And also there are several services, including service authorization, registration, and deregistration and discovery. And you can see here the figure explain the protocol for the service-based interface, which basically is HTTP version 2, and then the HTTP can have the payload with a binary, which basically the NAS and NVAP content, and sorry for the problem. We can continue again. So going in detail for the request response communication, basically in this kind of communication, the consumer will send a request, and then in a certain time frame, the producer will send a response. So you can see here that some HTTP method to create, read, and update, delete the resources. And then there are another kind of communication in which the consumer will send the message to subscribe to a particular event. And then when the event actually happens in the producer will send the notify to the consumer. And then also the consumer can send the subscribe on behalf of another consumer. So that you can see in the figure. One example of that in the 5G core network is that the SNS can use this kind of procedure to discover the ETF. You can see later, but basically the SNS we subscribe to the NIF so that when the ETF is up, ETF will send the registration to the NIF, so that the NIF will send the notification to the SNS. Yeah? By doing that, SNS can discover the ETF and do the association accordingly. Here's some example for how to create and modify and delete a subscription. We can go very fast because it's a web API or REST API. In the 5G, they provide few services. One of them is service authorization to make sure that the service consumer is authorized to access the service provided by the network service provider. And also network function service registration. You can see in the figure that the network function instance inform the NIF the list of the services that is supported by the service, and then during the for example network function instance registration and activation. Later we can check directly in the WhatsApp. You can see the information of the SMS, ANS, and ETF. Similarly for the service registration and service discovery, so that the consumer can be discovered by the another consumer. And again, the service stated subscribe and notify to be notified when any registered and updated network recently. So about the protocol stack, if you already know about 4G and LTE, it's very familiar. Only one thing different, the control plane protocol between the access network and the core network is NGAP. That means basically the counterpart of F1AC. And also we have the last, that's the last for the party. So we see here that the protocol between access network and AMS, and then also between the access network and SMS, the not the how to say the information element which is only for the section management is transparent to the AMS, so that AMS just transfer this type of information. You can see the NQSM information in the NAS, in the NGIP content from the RAN to the SMS. And here you can see the protocol stack for the NAS. Again, it's between EE and AMS, and it's transparent to the VLOD or access network. That is only for the mobility management part, and then you have the section management part is actually between EE and SMS, and it's transparent to the access network and we also have the protocol between SMS and EPF, is PXCP, which basically this protocol will be used by SMS to instruct the EPF to how to deal with the traffic between the access network and the core network. You can see here the reference so that you can define monitoring specification. About the user plane protocol stack, it's similar to the 4G version, so you still have a GPPE, but basically you have a new header for support 5G. So you can see also that in the demo and in the WhatsApp. Let's give an example about the SMS services. Basically, SMS is provide the services for the video system. And here, that you can see that SMS is actually playing the role of the server, provide a service to the AMS, and another SMS is one. Let's not talk about AMS. So the AMS will send the request to the SMS to, for example, to create a new video section. We also have the event exposure, so that the information of the for example, the US information, IP address will be exposed to the outsider. Maybe it depends on the scenario, but maybe application function will be conducted that, or maybe HTM, which is one of the components in the web bus, and I did mention yesterday. Some example with the OAI 5G core network implementation when we talk about network function registration and registration and discovery. So basically, the network function discovery will be used by the AMF to discover the SMS from the NIF, of course, using the request response. By doing that, we will need to configure the IP address of the SMS inside the AMF configuration file. That is very important for the paralytic one. You can have multiple SMS so that, for example, in the remote first line, you can see that we have two different EPS, and when the EPS up, SMS can discover ETF and if the ETF accordingly to the considered flight information or DNS information. Again, you can see some interaction between the IMF and SMF, and the figure here shows the way we implement according to CCTV procedure. So after the SMF register to the NIF, we have the bit procedure to fix up the section between the SMF and NIF. And the interaction between the SMF and ETF first is for the ETF selection mentioned earlier. But first, the SMF needs to subscribe to the NIF so that for the ETF notification event. And then when the ETF registered with the NIF, of course, SMF will receive the notification including all the ETF information. And then we also have the PXTP related procedure, basically to manage the relation between the SMS and ETF association HIT, and then also is to for the section measurement procedure, for example, to create the and for section to modify to release. So very quick on the registration procedure, basically 25 version from CPTP. So very quick on that. Basically, the GUP we select the IMF based on several information, for example, the network slicing information, PRMM, setting area information, and then after that, maybe we send the NG setup request to IMF to establish the FTP connection, and then if everything okay, IMF will send back the NG setup record. Everything okay, and then when the EE attached to the VLB, we send registration request. It's basically the NAV message, right? And then we use NGAP protocol to send the NAV message to the IMF, and then so on and so forth. In some scenario, IMF needs to get the identity of the EU, and then we have the identity request and response, and then after that, IMF will trigger the authentication or security procedure. IMF we contact the IUSF, and IUSF will contact India and get the information of the EU from the India. Basically, the authentication procedure, the information from the EV and from the connected should be not some critical information is OPC and FTI. We don't go into too more detail about that. And then after that, the IMF will contact the EDM to get the access and mobility subscription information, and also the same with the PCF. After that, the IMF will send the registration accept, and we forward the message to the EE, and then after that, the connection will be established between EE and IMF. And then at some point in time, EE can establish the previous section to actually transfer the traffic from the EE to the outside world, for example. And then we send the PDU section establishing request to the GUP. Of course, it's a NAS message. GUP, we use uplink NAS transport. Basically, NGAP to convey the NAS message to the IMF. Again, now IMF needs to select the SMS by using the services provided by the NIF. And then after discover and select the appropriate SMS here, IMF will send the video section create SM contact request. So you see that now actually IMF Treasurer client and SMS Treasurer server or service producer using the service and SMS services. And SMS needs to also contact the media to get some subscription information. Then if everything okay, SMS we select the EPS again using the services provided by NIS, and then SMS we uh, instruct the EPS to prepare for the PDU session. And then SMS also send the response to the AMS, including the tunnel ID information, so that the GDB run can establish the GTP tunnel between the run and the EPS. And also SMS can also input some QX information in the content of the NVAB message, so that the run can establish and create the resources accordingly. We can skip the last part because it's only for the first part is the uplink and the second part is down. We can skip that. You can see here some useful specification of the 5G. You can see some high-level 5G system architecture, procedure for 5G system, and then some technical specification also. You can have some specification for the protocol stack, and you can also see that some specification for each network function, AMF, SMS, and so on and so forth. So with that, we move to the second part of the talk about the OAI 5G core network and implementation. So just a few words about the OAI 5G core network project. You may already know about OAI brand, right? It's very popular for government. And at OAI, you also have the 5G project in yesterday, and we have also CI and CD project. So we have this project also. So you can see here the project website. So the main objective of this project is to implement a fully TCP compatible 5G core network stack, but on FM as an open source software. For this project, we have some sponsor from Hong Kong, Facebook, connectivity and digital, and until now we have some main contributors from OSA, EURECOM, DC, and Facebook. So this figure shows a very high-level view of the current implementation status of our OAI 5G core network. You see that we already have a lot of network functions already available. We continue to work to implement some network functions, for example, EDSF, service implementation, ECF, and also some network functions will be available in the future, for example, and that AF, STP. So go into two more details. So I would say that now we have a very solid and functional 5G core network. Of course, we support a very basic procedure with multiple EE and multiple sections at the same time, so that for example, you can establish a connection and also have the traffic. We also support some original features for cloud native deployment. Let's say we have an app registration network function registration and discovery, so that AMS can discover SMS and SMS can discover EPS, and also by doing that, you can have multiple AMS, multiple SMS instances, multiple EPS instances deployed in the core network. We also support some advanced features such as anti-handover. But unfortunately, we cannot validate that with the real testbed. We only validate that with professional testing. We also have Beijing STPD version 2 and FPDN support. One of the main feature that I want to highlight here is event exposure, which is very important, because we see that by expose the services of the network function, the third-party application or TCP application can get the information in real time, or the information or the network condition or something like that, so that they can connect the monitoring information, and then after that process the monitoring information and apply some uh, machine learning or something like that, and then, for example, can route the traffic according to the condition. For now, we have 6 events implemented for AMF, SMF, and 2 for AMF, and we are working to bring some more for EVM and EVM. And also, we have very basic support for private 5G network by relying on static IP address allocation, non-matrix traffic between the data network. And recently, we finished the network slicing support, basically fully compatible. And by relying on NSSF and also AMF, we are location coefficient. But again, unfortunately, we cannot validate that with a commercial or simulated video because we don't have this kind of coordinate. To deal with a 5G scenario, which is very wide range scenario, right? So how can OAI can deal with that? We provide you a very flexible tool, reliable, flexible, with different flavors. If you want the core network with only AMF, SNF, ETF, this works, no problem. If you want more functionality, you can pick the basic one with only AMF, SNF, NRF, ETF, EVM, AUSF, and EVM. And we have the full physical network implementation. Okay. So we have 3 different flavors. According to this scenario, the end user can pick one of them and deploy, right? And also with the same principle, we have 3 EPF flavors. The first one is SP-E, which is the in-house implementation. It's how to say, it's relatively easy to manage, easy to deploy, and of course with an outside that relatively performance. And then we have second option is VPP ETF from Jefferson. We support a bit higher performance with VPP support. And then the last option is with a P4 ETF that actually ongoing. We are working with the India to make the connection between SD fabric and of course we are always said that we push for the parallelship deployment. But we how to say, do support for more functionality with the parameter setup with VM. So we have 3 different options for deployment. In this demo, I will show you how to use Docker compose to deploy OAI in a few minutes. And then also we have the handshake to deploy even more automatic. So I said that we have a very stable. How can we have a very stable 5G network? Thanks to the validation of CI/CD project. So we tested and validated with a professional tester. Before is a DSF and now it's MD14. And of course, we are only focused on the functional stability and reliability test. We are working to do some tests with the performance. And also we test with OAI 0B, OAI E that you can see in with the demo. And also we test with the post-E. You can see here some list of the post-E and also Amarisot E. So we are very proud to provide end-to-end solution from the OAI to OAI 0B to OAI core network, so end-to-end XA network. And we also validated our core network with an open source run simulator such as we Thien, run Thien, and my 5G run tester. And more importantly, we also validate with some commercial GNB and post-E. Recently we also focused on because sometimes the end user think that it's a bit difficult for them to some configuration information when you connect between the LAN and the phone network. You need to set up the PMN information. You need to set up the network line information. So we are recently focused on bring some user-friendly API. For example, you can now have the API for the user provisioning. It's easy. And then you also have the API to get update the AMS SNF configuration on the. I will show you in the video. So that the AMS can be configured to belong to a specific line on the fly. For the roadmap, actually, we just released version 1.4. We focus on the scalability, but again, we have the list of features. You can find that in the release book. We are also working with some items to bring to the next release. For example, we actually now have the first version of the NEF, but we focus on the multiple ECS in the same data. It is very important because we support the branching point and uplink graphics here for the inter low latency communication and also to support that communication. We also working with the FlexCN component to test and integrate so that the FlexCN can consume the services exposed by the classical network and so to the end user. We also have the location service procedure in IMF. And actually, we have the NF, and then we do the integration later. And we also working with to support the Ubuntu 20.04 for the old network function. Actually, we already did with IMF, FMF, and media, but we have to take that on the rest of the network function. For the fourth quarter of 2022, we plan to bring some more advanced features such as IPv6 support and implement in DSS to support microservices, static implementation, redundant transmission support, and also support on 5G non-drive services. And we also want to bring more functionality, network functions, sorry, and that with that SCP on NMS. So with that, I will finish the first part of the presentation. Maybe we can stop for 3 seconds and then I go. Are there any questions at this point? So because this document you can see on the left, this new one, it's actually the instruction to this report. As for the this document, that is you have all the steps explained here. The first one is which one and we can take it on the network function. All the steps you have to just copy it and you have already did some digital links. We need to follow. So basically, provided by OEI in the business just that we need to some provide so if you want to modify some information in this, and remove everything that here using the auto control to so that your time you can see looking so just start to see that so you can relate that can relate because of the network when my computer can see when you can see now you see that all the network company up coming about basically you have all the network company you have AMS, SMS, ECS, you have NRS. Next step is to deploy the OEI application in 5 related and select the network. And you can see here and we also in real time that OEI will be actually started. We can just a few seconds so that we can and also check the lock the IMF. So you can actually see that we already connected to the SMS. We get a we see that the zero is actually connected to the second step is to deploy maybe I can also the WhatsApp so that you can see in real time. But we have a lot of exercise signal between the OLE and PNB, so we need to keep the Google FTP so that we can only display the corresponding information. Now I will do what the controls to actually the you see in real time that some strategies between the PNB and of the between authentication request, authentication request. After that, you can see registration that means registration. And after that, we can the CD system and targeting request to the connected to and you can check the IP address by using the app. So you can see here that the IP address will go up and up and up. Here, just we get a moment to delay the yeah, you so you see some information, network line information, company PNL information, our typical one. Also, you see the info PSI, that means the PSI information, that's the pricing with the for the GPP. We don't have that for the service, we have that. That's here. And also, you have the information of the uplink and downlink on the ID between the plan and ETS. Basically, the IPFS of the ETS and IPFS attached to the unit. Now, we do is to do the traffic thing between me and after work. For example, we can do that, we can do things with them. Let me do it. We go to the unit and from there we can start see again IPFS, and then we can do easily things. Know why? Because maybe you don't have DNS in this place, but let me ping the DNS. Maybe we can put here, maybe here. Yeah, it's because DNS will different. You need to modify DNS information in the configuration file of the SMS to make it work, because Google is not, the name Google is not, can be referred to the IP address, but this is F1S and SMS is you don't need to do that. So you can see here the thing which actually happens. So wait a moment and then you can see GCP which we have into ITNT inside the GCP. Then let me open one. Let me not you see you can see the tunnel. You see the source IP address. Basically, IP address right? 340. If you want, you can search that. And then you have the IP address. That's actually the package go from the new and then go to the tunnel. Maybe a PCS, because PCS is with the tunnel. And actually, the real message is and now to verify that is the IP address. If you want to verify the IP address, you know the ETS is just the then you can see this actually the IP address. So we can frame that actually the traffic goes to the tunnel between the unity to that. Something to show you. So with that, I finish the first part of the video. You have any questions for that? Then I will prepare for the sure that everything is there. I will put down the network and put out the range to the next 3 minutes. By the way, sorry, I don't remember the structure or the structure from the beginning, but I had the template, the C-sharp template in English. I'm sorry, I will tell you later. You have the C-sharp, and then you have the email for that. In this way, you have to. I will show you a little bit about that. You can see the content of the message. For example, you can see. You remember exactly, you see that in the content of the HTTP message, you can see that the vision part, and then you have the NAS and NGAT. So basically, the NAS message and NGAT now is varies in the HTTP. You check that NGAT and the application section. NGAT, and then all the information. Right. And then also we have a social event important. I will be very quick. And then we do the social event. I want to answer into the question about the latest values of the page. We option high because it's a simulation, right? The latest values of the page is just it from the inside to the code. Yeah, page. Yes. Yes, this week, the latest values were a little bit high, just because it's an explanation. Because of the simulation, and then the second one is because it actually have to pass the tunnel, right? And normally when you ping, you can do that better. When you ping directly from this computer to the Google, you have latency, for example, 5 milliseconds or something like that, right? And then in this way, you have maybe 10 minutes, because you have a long way to go to the, you have to go to the TV, because you need to cross the tunnel, then from the tunnel to the, you have several hops, so that it will increase the latency. For the second part of the loan, so let's talk a little bit about network, if you know about network. So maybe I will need to do this. Again, by the lot of we don't know which so this time this one will be which availability, you can support something like that. So how to deal with that. We all agree that not just writing one foundation for the budget file for this right when file so driving is that the network operator will build logical part of the network so that each logical part is actually a slide to support different requirements. So according to 3GPP, the network slice will be identified by a single network slice selection assistant information in bit or slide information, something like that. So you can see here that there are two important information. First one is slide of service type, SST, which define the how to say the expected network slide behavior in terms of feature. For now, we have some standardized value, one for MP and DMD, and so on and so forth. And then, according to 3GPP, the standardized value of the SST will go from 0 to 127. So we have this diagram, SST for standardized, and then above that from 128 to 264 for the operator usage. And then you have the slide differential SD, which basically to differentiate between the network slice. So you can see here in the figure that we have three different sizes for the control and user plane, and three different VN, different VN. And now go to the OEI, how OEI can support network slice. First, we have the network slice selection function, and then also we support the interaction between the AMF and SSF, the interaction between SMF and EDM, AMF and SMF. And you can find in the next slide. And we also rely on the IMF reallocation procedure. That means when the UE attached to the USB and send the request to the IMF, IMF may be configured with different slide, right? So in this case, IMF will contact and SSF discover another IMF which can handle this UE and pass the information to the subject IMF so that the UE can continue to enjoy the services. You can see here that in the figure, there are two UE with three different lines, and then the first UE established two different PU sections, but using the same slide. The second UE established two different sections with two different lines. So in OAI, we prepare that. I already showed you before the gamma file, right? So in this gamma file, we can define the slide information and which slide IMF support, which slide SNF support in the configuration file. Of course, we can do with a more advanced management and orchestration team, for example, we did integration between OSM and OER, OSM last year, and also we have integration with the PMR history, basically one of the main components in the network project. So let me give you a very deep flow for that. So first we attach a run, and the run contacts the INET, right? Normal. And then if, for example, we request the line number 1, but this INET 1 cannot support the line number 1. So what INET can do? INET asks an SSF which are the potential INET can support line number 1, and an SSF gives back INET number 2. That INET can support line number 1. So that so in this way, INET, there are two options. INET 1 can directly contact the INET 2 to pass the information of the UE. There is another option that INET 1 can contact the RAN to pass to reroute let's say registration request from the UE to the second INET. So that the second INET now continue the procedure. And the second INET asks again an SSF for the information of the NIF, the corresponding NIF, which can support line number 1. And after that INF trigger the procedure to discover the corresponding SNS. You see here that there are two include SMS 1 and 2. That maybe only SMS 1 can support line number 2. And then IMF trigger the procedure to select the SMS number. Again, SMS have to discover and select the appropriate ETF, right? Maybe we have multiple ETF, but only ETF 1 supports line 1, ETF 2 supports line 2, so on and so forth. So in this case, SMS 1, we select the ETF 1, and then after that, the traffic can go from EV to run to ETF 1 and to the EF. So in this demo, you can see this. It's very simple. I don't want to make it complicated. So all the control plane paths can serve two slides at the same time. You have slide number 1 with SSD1 and slide number 2 with 100 and basically operator defined. One is standardized value. So you test with two different values, different values. And you can see here that the AMF, SMS, ETF, and IF can serve two slides at the same time, but the RAN and ETF can only serve one slide. The reason is we have to deploy two different RAN because now with the simulator, it cannot support multiple slides at the same time. So that's why we deploy two different RAN for this. Again, for this demo, we first deploy the 5G core network as we see earlier, and then after that, we can deploy slide number 1, no problem, and then we can enjoy the traffic between the UE and the internet. And after that, we deploy the second slide, but we will do, because we don't have the ETF tool, actually, I will show you, we can add the ETF tool on the fly so that we actually create on the fly the slide number 2 and support the when the request is we do all of them manually. So let's go for the demo. What is actually I will again I will create or not yet. Again, you can see good boy. We will be replace the configuration file of the next here the configuration file actually the full right. Maybe we can do some to remove one to update the configuration file and remove again. You see now. Okay, it's better now. So you can see right now that ANS can only support one slide, right? And then now we connect the we connect the Actually, if you want to play, you can do like that. You can remove all the slide and then connect even the first will be. But in this way, you will get the MV setup. So that means the net cannot handle this again in here. Not PPT and not PMC. You need to create again the but when actually we remove the network, we remove also the disk, local disk, and we capture the location on the local disk, so that we cannot do that like that. And now we do again. We see the process, we see again. We have everything I put in the document so that we can take like even the system in the about that. Now I connect the view. Let's see, check that. So that's now we can move on with the actually in real time the second. Maybe you can have to wait a few seconds. Not in real time. Few seconds will be so now I can generate a topic for the not one because we can see that the traffic between the only one and after that we will deploy the second slide number 2 and will be number 3. This will be seen and this is one. So again, you can see in real time information. First, you cannot see the traffic. Now, let me show you the log of the SMS or IMS first. And then you can see that the only one connected to you. Because the limitation of the remotely seen is that when you have something wrong, this is standard and you have only one remotely connected. That means something wrong, right? You don't have the connection. You see here that, you see here that, NG setup failure. That means the internet cannot serve this EU and this remotely because we configure only support line number one, right? We don't support line number 128, right? So we can do it now. We do it. First, scope the humidity, and then we have the comment to state that. Then also we need to modify the beacon file for the element configuration. We put back the line number two, and then we turn the configuration file. So that element can support number two. But again, if we try like that, if we try update configuration, you cannot you see the result. You wait a moment again. The reason is you cannot apply when you have what happens when you remove the driver. You cannot deal with that situation. Right? Suppose that we want to add that we also can remove the line number one. And then we IMF is actually serving the EU and GDP. We cannot be like that, right? So now we have to stop the GDP and EU so that IMF don't have any EU to serve, and then we can turn the configuration normal. Now we have to stop the GDP. We take that. Then now let's try again to apply the configuration. Now IMF can support this line. And then you can do again to attack the network. Let's try to bring again this. To bring again the unity. Remove the product, remove to before. So now I bring the EV again. Now the traffic again. The traffic to red and not. So you see now it's we establish the traffic between the EV one and uh, outside, and then we do the same for the second EV and second UB. And we do get a moment. we try to bring all them down and then sorry for the problem. And we each few minutes to bring down everything and then set up again. We see again that we with the cloud native we that's only 3 minutes and then we deploy them. So that's that we also can shut down the whole network in 3 minutes. We protect the memory, something like that. Then we see the difference between the between how I have to use everything. How I have to use email and whole stuff of the run part. This now the physical part on. So you have a lot of filter between the EV and the delivery. So if you use one part, be careful. Then it is for capture the packet. A lot of specialty that we may have to do. For the problem, we got a moment 2 minutes and then we can do it very quickly. We reach the end of the video. When I restart that, I only show you that I already support the line number 2, but we don't have a PCF number 2, right? And then again, we see the problem. We cannot have traffic between EV number 2 and outside. Because we don't have because we don't have PCF number 2. And then again, on the fly, I will press PCF number 2. It's very easy. Just we click on then we can do it. Just a little bit. And we move on different now we little bit different in the phone. We can move on different that's like this, right? And then just repeat the take the complete out and then increase the station. A lot of between you see we don't have the IP address, right? And then now because we don't have the EPS number two, so that the SMS cannot first reach me. You can check that by by clicking the log of the SMS. Sorry, before we have the same issue that sorry, I realize that it's actually not a problem because we don't have EPS. Sorry for being this from here. And then we see that actually uh, see something here, not and we can check our actually, you see that there is there are no TV contacts to the network, and you see that the only one immediately connected to the network. So now I will deploy the second ECS. This easy is just go here and copy paste the second ECS. So now you should do is only copy the definition of the ECS and make it number two. You see something like that. This one is for the ECS, right? You just need to copy and then do some minor modification. First is the name, you have to modify. Okay, name is the and then you need to update also the ID. Number two, the CDN number two, and the last some information is about network line, right? We take here that this is here we support second line with DNN before and this line. And then also the last information is we have to put the IP address at this ECS, let's say this IP address. Now we can do the good element some delay. Now what we can do is to redeploy the network. When we redeploy the network, no, we don't need to delete. We just do that, and then the second EPF we add. But anything that we have sent into Nguyen. Yeah, now it's okay. Okay, good. Now you see that only the new ETF will be deployed. The rest is okay. Because we don't have anything for the computation. So only the ETF number 2 will be deployed. And now what happens when we continue with the unit DC? Bring it down first and then replace the unit DC. Then we move on to the deliverable. Then if you want, you can click lock the range. Now you see that the second really upload, right? With the default DNN, fly one of that and calculate and see with the IP address. So we secondly actually connected the network. So now how can we verify that this we actually uh, uh, we established we already established the traffic, the connection. Now we think and then verify that the traffic will be go from the taken to taken into us and to outside. What we do like that. So we can now think see what the IP address is being used, and then we can think this from the already, and we can use it. And then see the traffic. And now I will do one shot, take that, it's already good. We need to capture the TNT traffic. Then we check. See that number of packets in a lot. Now we can check that. We see that in wait a moment to processing. So we can see from the WhatsApp actually the traffic. So the first EE where the IP address of the first EE, right? And the second EE also. Then when you check the content of the GCP, wait a minute, GCP object from the second EE, you can see the difference. So you see here the content of the coupling packet. We see the IP address. The source one is 341, which actually not the USB one. We have to verify this IP address. And then we have the 245, actually the ETF2 that we remember correctly. I will verify that. Then we can verify that. I will here we can do what the input remove AI. Yes, yes, number 2. So you can see that actually the IP address 245 is EPS number 2, right? And then I will verify the unit thing. I don't remember so that I can do. I have to check the name of the we will be seen, okay, we will do the block. This one, basically, we will be seen, sorry, not that's not, not first. You see 241, if we will be seen. So now we can claim that there are two UE. The first one connected to the first UV, the traffic will go to the first ETF with line number one, and the second UE with the traffic will go to the second UV and the second ETF with line 128. It's totally separate. So we have the notion of the network line. That's very simple one. We have the common traffic plane. But of course, we can have a scenario in which one AMF serves line one, another AMF serves line number two, and we also have different SMS, different the other company. The notion is working. So thus, I can use my sorry for the delay and sorry for the open information. Any questions? I have a question. Because also, the using Vinod BC and VC ports and things like that. So what are the capabilities of this type of port besides just opening it up and like data connecting to the machine and maybe live ports to the core network? Like, can we experiment with something uh, more advanced than that? Like, for example, do some handovers or things like that? Handover, I don't think that we can do with the Zenobi scene. But again, actually, in our AI, we are have a plan to implement a new tester so that we can support more advanced features. But we will not have the first version. Maybe at the end of next year we can release the first version for that, and we hope we can provide some more advanced features. Like, 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 so with that, we close the second day of the monitoring. Something only operating and languages and